Okay, so in this video we will take a look into the workings of the cascaded shadow maps. So what I have here on the left side is the actual scene, and this is the main camera. This object on the bottom is the plane that actually is receiving the shadows and calculating the cascaded shadow maps. On the right side we see kind of a behind the scenes of what is going on. So the yellow frustum is the frustum of the camera from the left side, and these boxes, blue boxes, are the frustums of the directional light matrices. So basically these are different cascades of this directional light placed here. So this directional light is pointing to the world center and it's producing these cascades. So this is the first level, this is the second level, this is the third level, and this is the fourth level, and this is the fifth level. So what this does is basically it is calculating the shadow map in each of these different frustums. So you can see that each of these frustums is kind of a bounding box around camera frustum, and you can see the shadow not working very well on the left side. So basically what is happening here is these frustums, they render the scene from the light's point of view and save it into a depth map. So this is the first level, and it's calculating and rendering the scene from the light's point of view. And this is the here on the right you can see the depth map from this first frustum. You can see it doesn't intersect any geometry, so it's basically an empty map. The second one is this one, and it's intersecting some of the geometry, and you can see it here on the right side in the depth map. And then we go to the next level, and this level intersects some more of the geometry. And then fourth level is this frustum, and it's producing this shadow map. And then to the final level, this is the final level, and you can see it's producing this shadow map. So all of these work together to create multiple levels of the shadow mapping. So this object on the bottom that you can see here is a plane that is receiving the shadow, and actually its shader is calculating different shading levels depending on which cascade the fragment of the plane is on. So here color coded are each of the levels. The red is the first level of the cascade, so it's using this shadow map and this frustum to calculate the shadow. Since there is nothing there, it is producing no shadows. The second level is coded in green, and you can see it's producing some of the shadows at some points and at some fragments. And then the third level is blue coded and is containing some of the geometry. And then go to the fourth level, which is in pink, and then fifth level, which is yellow. So what is happening here is it's not working properly, and this is because, as you can see, the frustum is not going all the way to the plane, and that is because each of the fragments of the plane are calculating the depth, and then they're comparing their depth to each of the depth of the light's frustum, of the light's cascade frustums. So if the depth of the fragment of the plane of the object that is having shadow casted on is being compared to the light frustum, and if is beyond it, it will not use the light's cascade shadow map to calculate the shadow. So what we do here is we basically multiply the set of the lights cascades for shadows with some multiplier, so that we elongate the lights cascades frustum, and then it looks like this. So the first cascade is elongated along the z-axis and is now, if we take a look closer, this is the red coded, the first cascade is red coded, and we can see it's producing a shadow here on the left. And this is because it is now intersecting some of the geometry for the first cascade. The same principle applies for the second cascade, which is coded in green, and you can see shadow here appearing on the green portion of the plane. And then the third map, it's this shadow map, and it's containing all of the objects in this blue box, blue frustum. The frustum is a box because directional light shadow mapping frustum is orthographic projection, so that's the reason why it's basically a box. And of course the next level is blue, and then the next pink, and then the next yellow. So we can see it here. So this is how cascaded shadow maps work. And if we take the camera and go to the settings and increase the far frame of the camera and then zoom out, we can see that the actual first level of the cascaded shadow map is actually the only level that we need here. And then the second level is green. And as we zoom out, we can see that different cascades, or actually different shadow maps of each level of the cascade, is impacting the individual fragments on this casting object. So yes, that's basically what cascaded shadow maps look like and how they work. So if we zoom out, we will see that the next cascade is taking over, and so on until the last one. And when we zoom out all the way, when objects are not in the camera frustum anymore, behind the far plane, then we don't see objects anymore. So yeah, that's how cascaded shadow maps work in principle. And you can also see that this first level, this level, is containing the most detail, and then the second level, the green level, is containing less detail because it's rendered from a bit far out. If I go back and reduce these frustums just for illustration, you can see that their division is kind of non-linear, so you can use kind of a calculation where the last frustum taken from the viewpoint of the light is the biggest one, and then the first one is most tightly surrounds the camera. So yeah, that's basically it. Thank you for watching.